So welcome back to the new video on NQueen problem. If you look at the previous video, I have explained you the constant logic in which uh, the formulation of how the diagonal elements are rejected was described, and the formula which we derived was absolute value of I minus k is equal to absolute value of j minus l. So if you want to go into further details of this formula, you can just refer my previous video. What I'm trying to explain in this video is we would try to solve the 8 queen problem, and we'll try to understand the algorithm for the generic solution of n queen problem. So if you look at the the screen and the matrix shown on the screen, it is a 8 by 8 matrix. So we are trying to place Q1 to Q8 here. And it is assumed that uh, some of the queens are already placed. So these are the rows 1, 2, 3, 4, 5, 6, 7, and 8. And these are the columns 1, 2, 3, 4, 5, 6, 7, and 8. So how many queens we are going to place is 8 queens. And since we are trying to understand the constraint logic and its implementation here, we are taking a partial solution. Like our, if you check, like our solution will be placed in X array, which will be having the index as 1, 2, 3, 4, 5, 6, 7, 8. So this index represents the queen numbers, okay? And whatever we are writing at the index represents the column number. So if I write 4, it means that Q1 is placed in column 4. If I write 6, it means that Q2 is placed in column 6. And if I write 8, it means that Q3 is placed in column number 8. Okay, so this is column number 6 for Q2, column number 8 for Q3, and column number 4 for Q1. So if you look at the constraints, if I place Q1 here, this entire row is not allowed, entire column is not allowed, and the diagonal elements are also not allowed. We are just assuming that this constraint is already checked. When we place Q2 here, again the row is not allowed, column is not allowed, and the diagonal positions are also not allowed. And when we place Q3 here, again the row is not allowed. So you can see some changes in the color wherever possible. And the columns are also not allowed, and the diagonals are not allowed. So idea is very simple. When we place Q1, we will discard some of the cells of row and the column and the diagonal. When we place Q2, some of the cells of row, column, diagonal, and so on. Now the question is where to place Q4. Okay. So when we are saying where to place Q4, we will search row number 4. And as column number 2 is currently vacant, Q4 will be placed here, and then we will try to check whether this Q4 placed here is basically having the constraint satisfaction. It means that there should not be any queen in the column number 2. Okay, there should not be any queen in the row number 4, which is not there right now, and any particular diagonal position should be also not allowed. So you can see here this diagonal, okay, is free. This diagonal is also free. Okay. So from the pictorial representation, it is clear that this 2 is valid for the location for the queen 4. Okay. Now, what we'll try to understand is we'll try to understand the algorithm, and we'll try to see how this algorithm works. Okay, so now let's go ahead to the next slide. We are assuming that the solution will be stored in the array named as X, and there will be n positions in this array where n represents the number of queens. Okay, so for example, if we have q equal to 8, then n will be equal to 8. And we have already passed, or we have already placed the queen number 1, queen number 2, and queen number 3. Okay, now we are trying to place the queen number 4 at this particular position, which is the location, fourth location in the array. Okay. So how to do this and how to check whether the constraints are satisfied or not, that we are trying to understand. So if, for example, if at location x3 the value is 2, it means that in the, so if at location 3 the value is 8, for example, so x of 3 is equal to 8, it means that the third queen is placed in the 8th column. So divide the algorithm into two parts. This particular process has divided the algorithm into two parts. First part will just pass the value of queen, and second part will generate the location. For example, if I say first part will pass the value of queen, which is 4, and second part will generate the location, which is right now, according to the constraint, it is 2. So we will try to prove that if I try to place Q4 here, then it is not permitted. That's what is the idea. Okay. So it's very simple. A NQueen is the name of the algorithm, and K is the first parameter and N is the second parameter. K will be 1, followed by 2, 3, 4, and up to K will be 8. And similarly, n will remain constant, that is 8, because we are trying to place the 8 queens in 8 by 8 matrix. Okay. So a simple loop is executed here for j equal to 1 to n, because we want to check whether the first queen can be placed in column 1, column 2, column 3, column 4, column 5, up to column 8. So assuming that 1 is placed in column 4, 2 is placed in column 6, and 3 is placed in column 8. Okay, this is our initial assumption, and we are trying to check whether 4 can be placed in column 1, 2, 3, 4, 5, 6, 7, 8. So if you recall our idea, actually 4 will be not placed in column 4 because it is already used by 1, column 6, and column 8. So if you check our array X, it has already 4, 6, 8, and we cannot write 4, 6, 8 here, because if this is the kth location, then this locations will be 1 to k minus 1, and already in these locations we have used either 4 or 6 or 8. So at this place 4 is not permitted, 6 is not permitted, and 8 is not permitted. We are trying to check whether remaining values like 1, 2, 3, okay, 5, 7. These are the remaining values. So out of these remaining values, which value is permitted in the sequence of 1, 3, 5, 1, 2, 3, 5, 7. Okay. So it's very simple. Place k comma j is the next algorithm which will check the whether the column j is valid for the queen k. Okay, and if it is valid, it will place x of k equal to j. It means that x of what? 1 equals to 4. First queen is in the fourth column. And if k equal to n, that is our regular idea. Write x 1 to n, that is your output array. Otherwise, increase the value of queen and continue with same number of columns. So this is a simple part one, where we are just passing the value of k one by one, keeping n constant. Now, I have already explained this idea. Like if you want to solve for k, you must have solved for 1 to k minus 1. So with this assumption that we are trying to solve for k equal to 4, assuming k equal to 1 to 3 is already solved. So look at this board. Again, the same board was there in that previous slide. We are trying to place Q4 here. And with this idea, we are trying to check whether this Q4 at column 1 is permitted or not. Very clearly seen it is not permitted because it is diagonally opposite to Q1. So assuming 468 is already occupied with from 1 to 3, we are trying to place the queen number 4 in the column number 1. So our call will be 4 comma 1. Okay. What is k? 4. And what is the value of column? 1. So with this assumption, again I am repeating that we have already done the calculation for 1 to k minus 1. So our X array looks like this: 4, 6, 8, and we are trying to store 1 here. So first condition satisfies. For I equal to 1 to k minus 1, if x of I is equal to j. What is j? J is 1. X of I is 4. X of I is 6. And x of I is 8. So for all these three values, it is not equal to what? 1. It means that that particular column has not been used till this time. Okay. Let us move further and try to add the second constraint, that is the column constraint. So we have already discussed absolute value of I minus k is equal to absolute value of what? J minus 1. So here we are not using the variable variable L. Instead of that, we are just using a variable which is already available in the form of index of array. So our formula is slightly modified. It is absolute of x of I minus j is equal to absolute of I minus k. This k is nothing but the queen number, that is 4. This j is nothing but the column number, and x is already known to us, I is already known to us. So if you take this whole formula in expansion, so what is x of I? It is 1 time 4, 1 time 6, 1 time 8. What is j? It is constant. That is, what is the value of j we are passing every time? We are presently passing 1. Okay. And if it is equal to absolute value of I minus k, so I will be varying. One time it is 1, second time it will be 2, third time it will be 3. Okay, correct? So this is a variable 468 because this varies with the value of I, and this is the variable because it is itself I. Okay, and what is again k? K is constant, which is our queen number. So we are writing here what? 4, 4, 4. So now 4 minus 1. So all these things will be taken for what? Everything will be related to absolute here. Now we take 4 minus 1 equal to 3, and 1 minus 4 also equal to 3, and then because both are same, it will return false when the value of I is 1. Okay. So then in that case, it is very clear that the value of j equal to 1 is not permitted because it is returning what? False. Now let us further try to understand whether the value of j equal to 2 is permitted or not. So I'll just keep this: j equal to 2 is permitted or not. So when the value of j is 2, in this formula, only one part is changed, and that part is nothing but this particular position. So now I am just replacing this value with what? 2. So 4 minus 2. and 1 minus 4 not equal, 6 minus 2 and 2 minus 4 not equal, and 8 minus 2 and 3 minus 4 not equal. So it means that if you are using for this queen column number 2, then it is permitted. Clear? Now, when we are saying column for Q4 column number 2 is permitted, all these cells will become invalid for the coming queens. Okay, and probably you can see that as you go down, the number of cells are which are available for the queens will be further reduced down. So if you take now queen number 5, probably you are using either column number 5 or column number 7. So with this constraint, it is very clear that in this for loop, if one of the condition is not satisfied, the return value will be false. So let us try to put one more example. Like if I want to try for 3 here, whether it is permissible or not permissible. So I will just take 3, 3, 3. So 4 minus 3 is 1, 1 minus 4 not equal, here also not equal, and here also not equal. So probably you are allowed to still go with Q4 here. Okay, let me show you that how Q4 at column number 4, not allowed. So very simple. Here this condition will be satisfied. Okay, and if I try to place Q4 at column number 5, then only thing replaces this 3 will be replaced by what? 3 will be replaced by 5. So if I replace 3 with 5, 4 minus 5 is 1, 1 minus 4 is 4, 6 minus 5 is 1, this is 4. Oh, sorry, here it is 3, here it is 4, here it is 3, here it is 2, here it is 1. So nowhere, so here 6 minus 5 is 2, and this is 2. So 6 minus 5 is 1, and this is 2. So still the condition is not satisfied. So maybe this is not allowed, this is not allowed, maybe this is allowed, Q5 or Q4. Sorry. So with this all, I think the idea of implementing the constraint is also clear. Uh, so this video explains how to basically execute or how to basically demonstrate the execution of NQueen problem. Thank you very much.